which one of the following best explains why this happens? Caesar, let's start with you today. Which one did you say? Okay. So before we get to his answer, can positive things move? No. So immediately we can scratch out A and C. All right. Now he said B. He said negative charges are transferred from the rod to the wool. Which one became negative? A rod acquires. What does the word acquire mean? Get, obtain, become. A rod becomes negative. So can the negative things go away from the rod? No. It had to get to the rod. So it's not B. It's D, where it says negative charges are transferred from the wool to the rod. Okay, now ladies and gents, in science, let's say your exam now, count 75 marks and you are going to get an hour and a half. That is 90 minutes. Okay, now how science works is each mark must get 1 minute. And then you have extra time. So you already get extra time in science. Okay, now multiple choice questions, each counts 2 marks. So that means 2 minutes. That means 120 seconds. 1, 2, 3, 4. That's a long time for this. Use it. Alright, some multiple choice questions will go faster, but don't think multiple choice is definitely not how well can I guess? How well can I spot the answer? That is not multiple choice. Multiple choice is a testing of a concept. Alright, so you are going to get in every test and exams from now on until the day that you pass matric, will every multiple choice question in science, or you in every paper, there will be 10 multiple choice questions. 20 marks. 20 marks out of your 75 marks is a lot. So you spend time on that. Right. Next it says, a learner is in a physical science class, rubs his hair with a plastic rod. The rod becomes negatively charged. The learner now opens the tap. So the thin stream of water runs from it. When it gets close to the tap, blah, 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 it goes towards the water. Okay. Now, you as a scientist in my class must inquire and question everything that you do not know, that you do not understand. That is what scientist does. That is what the whole science field is about. You see something, you want to understand why that happens, how that happens. Is it the truth? So when you read a question like this for homework, you must think, is this true? Okay. Now, do you all have a plastic something at home? Yes. Yes. If you don't have, then you're not living in the 21st century. Okay. It's a different topic in Paris. Do we all have running water? Not all of us. But you can make your own tap by doing what? By getting water in here, taking another bucket and making a stream. Yes? So you should have gone, when you've got this at home, you should have gone and thought, I wonder if this is true. I want to test this. Okay? Right, so I'm taking it says it takes a rod, but I guess you don't have a plastic rod at home. Okay, so you remember this, now it's negatively charged to the balloon. You all see? Okay, so it's true. Okay, and we want to know now, as scientists, why that happens. How does it come to be like that? Now they ask there, write down the principle of conservation of charge in words. Where do we start? Yes, Amara. Oh, sorry, you have to speak up. The net charge. Yeah. Okay, now grade 10s. 30% of your question paper must be theory, like definitions. So if you know theory or definitions, you at least, or already have at least 30%. That's a lot of marks. So go study your definitions. You will most definitely get a definition at every question. I think your question paper consists of 6 questions. So in every question there is a definition or 2. 1 or 2 definitions. Alright, so please. Okay, next one. Give a reason why the stream of water bends towards the rod. And this counts 3 marks. Okay, 3 marks means 3 ideas. Not 3 words, not 3 facts. 3 ideas brought together. Okay, so I normally do it in 3 bullet points, so I know what goes together. So I'm going to do this one. Okay, the first thing that we know is the rod is negative. The water, I'm going to zoom in here. I do not know if that is positive or negative, so I'm going to assume the water is neutral. That means it consists of protons and electrons, positive and negative things. So what will happen when you bring a negative thing closer? Will it attract the protons? Can protons move? No. So it will push away the electrons. It will push away the negative particles so that the protons are exposed, are on its own, and the electrons are pushed away. So what happened here is we polarized the water. Remember yesterday with the electroscope? And we polarized it, and I explained that. Okay, so when you bring this negative thing closer, you polarize the water. And then the positive is attracted to the water like that. Now, the reason why it goes together, the water, and not just like one water molecule, is because of hydrogen bonding that you will learn in grade 11 about. Okay, so my first bullet point is saying that when the negative rod is brought close to the water, now water, I'm using the symbol or the formula for water. When the negative rod is brought close to the water, the negative charge repels the electrons on or in the water. Thus, it polarizes the water. That's 1 mark. Okay, thus it polarizes the water. Now the water has a positive side. Yes? Well. Okay, so now the water has a positive side and a negative side, and the rod is negative. Okay? Okay, so the water now has a positive side. The rod is negative. What do we know about positive and negative? It attracts. So you say that positive and negative attract. Thus, water is attracted to the rod. Okay. I'm just quickly gonna do something there. Okay. Now it says, during the rubbing process, 10 to the power 14 electrons are transferred to the rod. Calculate the net charge on the rod after the rubbing process. Really? What is net again? The total, the sum of everything. Sum means adding. Positive and negative things when you add that together. Sum of everything. Okay, so they ask, or they say how many electrons were transferred, and then they want the charge. How many electrons? Okay, so I know I'm all over the place here, but you are doing it in your writing book neatly. So for this, we're going to use the formula N is Q over E. This thing, so it counts 3 marks. 3 marks means formula, substitute, answer. Always. When they say calculate, and you see 3 marks, you know formula, substitute, answer. Okay, so that is the formula there that tells you 10 to the power 14 electrons were transferred. They want to know the charge, and the charge of an electron you will find on your data sheet. Yes. Where? You can't see. You must please get glasses. But then where are they? Why? You know you are spoiling your eyes even more when you don't bring your glasses. Have I ever seen you wear your glasses? Okay, to me, this is your question to calculate. And remember, you don't trust her. Yesterday. That's convenient. Since yesterday. What is your plan, Sizwe? I hear a problem, I want to hear a solution. Your parents are going to buy you another expensive calculator. You have very nice parents. My parents would have said I have to work for money to get a calculator. Yes to me? Yes? And the unit? Charge. What does C stand for? Coulomb. Alright, next one. I think is a multiple choice question. Are you all done? Okay. It says there, 2 identical spheres X and Y on insulated stands. Just means that they can't lose their charge. There's not a conductor of electricity. Carry charges of 3 microcoulomb and minus 5 microcoulomb respectively. Actually, now what does the word respectively mean? Nothing to do with respect. Read the sentence. X and Y carry charges of that and that respectively. Oh, now Right. So we will go on while she looks for it. The spheres are brought into contact with each other and return to their original positions. What happens when they are brought into contact? There's a transfer of electrons until they are equal, until they are the same. The charge on each sphere after contact is, now you see you do not have to convert the microcoulomb because the answers are given in microcoulomb. So it's easy. When they touch, you think of the formula Q1 plus Q2 over R, not over R, over 2. Why? Because there's two charges. So we have 3 plus minus 5 over 2, and that answer is what, Umulemu? Don't put on your calculator. No, but so the answer is not C. 3 plus minus 5 gives you what? Negative 2. Divided by 2?
So, then every time we get the answer, let's divide it by 2.
If there's 2 things that touch. If there's 3 things that touch, you divide by 3. If it's 4, you divide by 4. Yes, Asina? No, loud, because there's a lot of people that do not know what the word respectively means. Loud, like you're announcing something. Can you say anything loud? Do you ever like get excited about something? Say it, and then you speak loud. Respectively means relating separately to each of those in question. Okay? So when we say respectively, we mean that X, there we go. X is 3 and Y is 5. That's what we mean with respectively. Relating to, what does it say, fancy words? Relating separately to each of those in question. So we could have written X, which is 3 microcoulomb, and Y, which is 5, negative 5. Or they can say X and Y, respectively 3 and negative 5. Yes? There was something else that I wanted to say. Alright, next question. It says, a neutral plastic ruler becomes charged when it is rubbed with a wood cloth. After rubbing, the ruler has a charge of that. In other words, distinguish between a neutral object and a charged object. Umulemu. No, you did answer. Genevieve.
I said in a neutral object there are as many protons as electrons. A charged object either has more protons than electrons or more electrons than protons.
Perfect. Okay, so you have to explain both. You can't just say what is a neutral object, because they'll ask you to distinguish between, to describe both. Okay, so a neutral object has as many electrons as protons. So the number of electrons is equal to the number of protons. Where a charged object, they are not equal to one another, meaning the electrons is not equal to the number of protons. So you can either say it like that, they are not equal to one another, or you could have said there's more electrons than protons, or more protons than electrons, or you could have said the object lost electrons or the object gained electrons, or you can say there's excess electrons and a shortage of electrons. So there's lots of ways to describe it, but you must describe both. Yes.
Is it on what do you see?
A what?
Is it on what do you see?
Yeah. Okay, now it asks Carabello, does the ruler gain or lose electrons? Why do you say it gained? Yeah, it's an easy question. It was neutral, and now it is negative 3.5. What did you say it gained?
Because the electrons are transferred to the.
How do you know it was transferred? What gives you the clue that it's transferred? Don't overthink it. What did you see and you thought, it must have gained electrons? You'll see, everyone knows this answer. No? 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 Ja, let's say who? Of the ruler is now what? Negative. The fact that it has a negative charge indicates that it has gained electrons. Yes? Yeah? Okay. Next one. Calculate the number of electrons transferred during the process. Calculate 3 marks. Formula, substitute, answer. Okay, so the formula that you're going to use is N is Q over E. The charge is negative 3.5 times 10 to the power negative 15. The charge of an electron is on your data sheet. And when you calculate that, what do you get, Karabu? 1875 times 10 to the power of 4 electrons.
Now, if you leave the. Is it going to be 1?
Yes.
So make sure that I mark it 1.
Yes. And then you put an E next to it. Okay. Now they ask, the charged ruler is now brought closer to a piece of paper. The pieces of paper are attracted to the ruler as shown below. Explain why the pieces of paper are attracted to the ruler. Counts 3 marks. Those are those 3 bullet points that we have discussed on the previous paper. Okay, so the ruler is negative. And then the pieces of paper, when they are brought closer, are going to become polarized because negative and negative repel. So the electrons are repelled. There's a positive strip and then it's attracted to the negative. So the Sehu, please try those 3 bullet points that we did. Say again. We hold your hand. No, that's not the first one. When the this D, and it's very similar to question 5C. No, 5B. Okay, so you don't just sit and wait for the Sehu to answer. You think for yourself. See if you can figure it out. Yes, Lesego? Ready when you are? Do you have your answers open at 5B?
Yes.
Okay, now please apply those same things to this question. Instead, where it says rod, you're going to say ruler. Where they say water, you're going to say paper.
When the ruler is
When the what ruler?
when the negative ruler
Yeah.
is brought close to the paper, the negative charge repels
The electrons on the ruler. Yes.
paper.
Say what you want to say. Say the sentence again. Let me hear.
The whole sentence is
Yes.
the negative ruler is brought close to the paper of the negative charge. Amen.
So what did you copy at 5b? Okay, let's say, stop. When you copy, you must please copy correctly. Is that what I wrote down? When the negative rod is brought closer to the water, the negative charges repel the electrons. Do you want to quickly correct your things?
After electrons, what stands there?
On or in? Water, H2O,
Yes.
comma, thus, it polarizes, they must say the water. The water. Okay, are you ready, Lisechel? Okay, go for it.
When the negative ruler is brought to paper, the negative charge repels the electrons on the paper, thus it paralyzes the paper.
Yes.
The positive and negative aspect.
Then,
Thus, paper is attracted to the
yes,
On the second bullet, if you would opposite charges.
perfect. Yes? Let me just ask this. Let's say, did you understand what you wrote down? Because it doesn't help you write down something and you do not understand what you've written down. Then you remain stupid. When you ask, you learn something. Yes?
I don't understand.
You don't what part do you not understand?
The first line.
Okay, so you understand the sentence when the negative ruler is brought closer to the paper, sharp. Then the electrons on the ruler repels, you know what the word repels means? Repels the electrons on the paper. So, I'm going to do this in a moment. So, in here, said the ruler was negative or is negatively charged. Now, I've just enlarged this piece of paper. Okay, so there's the piece of paper. And a piece of paper consists of negative and positive things, lots of them. Yes? So when the negative thing is brought closer to there, what do we know about negative and negative? Repel. So what will happen then is the piece of paper, all the electrons will be pushed away so that the protons or the positive particles are left on their own. Okay, so when this negative thing, wait. Balloon negatively charged. When this negative thing is brought closer, the wall, so you can see the protons and electrons. When the negative thing is brought closer, what happens to the electrons? They are repelled. Okay, so imagine this balloon is the ruler and the wall is the paper. When you bring the ruler close to the paper, it repels the electrons. So the wall becomes polarized. It gets two poles. It gets a positive pole and a negative pole. And what do we know about positive and negative? They attract, that's why they come close. Sharp. Anyone else? Yes.
You said the ruler is negatively charged.
Yes.
How do you know that it's negative? Because it doesn't say the text.
Okay. It's good that you ask. Any more questions? Sure. Remember, when you do not ask, you remain stupid. When you ask, you learn something. Yes? All right. Okay. Multiple choice question. It says, 4 identical balloons, each carrying a charge of blah, 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 are suspended from a ceiling as shown below. B is negatively charged. Okay. So they tell us B is negative. Tell us. If B is negative and it's attracting A, what must A be? Positive. Okay. Then we see that C is attracted to B. So what must C be? Positive. And then we see that D is repelled by C. So what must D be? Positive. Okay. So now I check. A must be positive. C must be positive. And D must be positive. So B is the correct answer. Yes? B is the correct answer. Okay. Next question. It says there, 2 identical insulated spheres, X and Y, suspended by thread from ceiling, are held at a small distance apart as shown below. So they give us the charge of X, and they just say Y has an excess of electrons. Now, Atlehang, when they say Y has an excess electrons, do you think Y will be negative or positive? Negative. That is why it shows it's negative, because it has more electrons than it has protons. Okay. Now it says they calculate the magnitude. What does the word magnitude mean again? You read a word and you do not know what it means. Then how can you answer the question? Calculate the magnitude of the charge on sphere Y. So magnitude has 2 meanings. The one that we're looking at is size. So the amount, the amplitude, the extent, the mass. So when they say calculate the magnitude of the charge, we always use in science the word magnitude. It means the size of the charge. How big is the charge? So you will always read the word magnitude. Okay, so they say calculate. You see it counts 3 marks. So it means formula, substitute your values, and then answer. And when you calculate that C2A, what do you get? And the unit? What does he stand for? Coulomb. Right, next one. The spheres are now released and they move towards each other. Give a reason why sphere X and Y move towards each other. Now this counts 3 marks. It seems like an easy answer, but you must give 3 ideas for 3 marks. So you must be answer very elaborately. Answer things that you think are common sense. Yes, Amara. Okay, so this is not polarization that you're explaining now because it's already negative and positive. If you have, like we had here, you had neutral paper or you had neutral water, then there's polarization and then it's these 3 bullet points. But these 2 things are already charged. So there's no polarization that occurs because it's already positive and negative. Okay, then you are just going to say the very, very obvious. You're going to say negative and positive attract. That's your bullet point 1. Or opposite charges attract. Then you're going to be very specific. You're going to say X is positive and Y is negative. Thus, X and Y attract. Okay, so being very thorough. Positive and negative attract, that's a concept, an idea. Now we're being specific. X is positive, Y is negative, so that is why they will attract. Okay. Next question, the spheres are allowed to touch each other. After touching, they move away from each other. Okay, so they're allowed to touch and then they move away from each other. Calculate their charge on each sphere after they have separated. Okay, so calculate 3 marks, formula, substitute, answer. Formula Q is Q1 plus Q2 over 2. The one charge is 4 times 10 to the power negative 18. The other charge is negative 4.8 times 10 to the power negative 18. Divided by 2, and really what do you get?
I get -1.
Negative?
1.
Negative? It's not negative 1. No, divided by 2. Yeah, times 10 to the power. And the unit, which is, thank you. I think that was the last page, no? Yeah. Okay. Now we have not done on the first page. We haven't done 1B, C, 2B, C, and 3A, B, C. Yes? Okay. So we're going to do that. Ach, nee man. Alright, so it says at question 1, I know we've already done 1A. I'm just quickly going to recap. At question 1, they say you have plus 50 millicoulomb and you have negative 50 millicoulomb. They are brought into contact and then separated. Alright, at 1A, they ask what is the excess electrons on the negative 50. We've already done that. At 1B, they say calculate their charge after making contact. So they've made contact. Okay, so it's Q is Q1 plus Q2 over 2. That is 50. Now milli, we don't work in milli, we work in coulomb. So it's 10 to the power negative 3. Plus negative 150 times 10 to the power negative 3 over 2. And when you are ready to me. The calculator, that's not working. It's the operator. Yeah. And your unit? The coulomb. All right. Then question C. A question that do not ask often. So I'm not. We're going to do it 3 times and that's it. So ask how many electrons are transferred during contact. Okay. So these two made contact, and now they have equal charge. Okay. First of all, were the charges or the electrons transferred from A to B or from B to A, Asina? When they made contact, these two, there's a transfer of electrons. Is it from A to B or from B to A? What can transfer, positive or negative things? Does this one have excess negative things to transfer? This one is positive. It means it has a shortage of electrons. This one has an excess of electrons. So the electrons were transferred from this one to that one. And they want to now know how much were transferred. All right. So when you do that, how much? So the number of electrons transferred. This is a formula that is not on your data sheet. Then you're going to say the old one, the old charge, minus the new charge over the charge of an electron. So you don't have to write this formula down in a test or in an exam because it's not on your data sheet. So old one minus the new one over the charge of an electron. The old charge, now you can choose any one of the old charges. Okay, I always choose the positive one. It's just in my head, but you don't have to. So 50 times 10 to the power negative 3 minus the new charge is the one that you've calculated. Negative 5 times 10 to the power negative 2 over the charge of an electron. Omulemu, when you are ready. Yeah. Like you don't have to type it into your calculator or what? No, don't delete. I want to see what you've done. Type in again. Yes, Umulemu?
Negative 6,253 to the power 17.
That is how many electrons it gained. Alright? Okay, question 2. They say there you have 36 microcoulomb and you have 100 microcoulomb, a negative 100 microcoulomb. They are brought into contact and then separated. We've already calculated 3A. We ask how many excess protons we have there. Okay, we already also said that this is times 10 to the power negative 6 and this is times 10 to the power negative 6 because it's a microcoulomb and we want to transfer that into coulomb. Where's your negative? 50. And why do you not use your fraction? So I don't want you to type in the matrix. I want you see your fraction. You see your bracket. I want you to type it in the fraction bracket. Okay, so 2A we've already done. 2B, calculate the charge after making contact. So 36 times 10 to the power minus 6 plus negative 100 times 10 to the power negative 6 over 2. So they've made contact and separated. And on it. Great, things. Please write it like I write it down here. So you write your formula, and then the equal signs must be underneath each other. Okay, like that. Okay. Now, why is it like that? Because the calculator is not in time for the notation. Yes, Genevieve?
Then I got -3.2 times 10 to the power of a -5.
Your unit?
Is coulomb.
Right? Then at question C, they ask you how many electrons were transferred. So the number of electrons transferred is your old charge minus the new charge over the charge of an electron. Your old charge, now you can choose anyone. Like I said, I normally choose the positive one because that is just what I am used to, minus the new one over the charge of an electron. No, I don't have space. And Karabeli, what do you get? Yes. Don't delete, I want to see what you're typing. Yes. Bless you. No. You see that formula is not on the data sheet. Sorry? Where are we? Carabello, yes? Electrons. What's wrong?